and welcome to all the viewers. Today we are going to look at an introductory session to statistical tests. Until now in statistics we have had a look at what are the different descriptive and the numerical and graphical summaries which we can do. And one of the sessions also talks about hypothesis testing. So we are moving on to inferential statistics, and of which we are going to look at what are different statistical tests, and the most important aspect is how do we choose the right statistical test for the data that we have collected. So to begin with, let's have a short recap of what we have seen earlier as to firstly what is statistics. So as we all are aware, it is the science of collecting, organizing, summarizing, analyzing, as well as making meaningful inferences and conclusions from the data. And there are two main types of statistics which we have looked at. So if we divide the whole thing into two, we have one variety as descriptive statistics, which deals with the earlier part of collecting, organizing, summarizing, analyzing, and presenting data. Now, when we talk of descriptive statistics, we have already looked at what are numerical summaries in terms of the measures of central tendency and measures of variation. And we have also looked at the various graphs and charts that can be used to present our data. The second aspect, which is inferential statistics, includes making inferences, hypothesis testing, determining relationship between the variables under study, and possibly making predictions from the data collected. So what we are going to discuss today or focus on today is the inferential part of statistics. We have already had a look at what are measures of central tendency and presentation of data. Today we are moving on to more specific things as to, under hypothesis testing, what are statistical tests of significance. Now in earlier sessions we have looked at, we need to understand what are the different types of variables before we actually proceed on to your data analysis. So for example, the type of variable which you have in your data collected is going to help you understand what kind of statistical tests you are going to use. So for example, if you are using continuous variables, okay, in this case you are going to use measures of central tendency like mean, mode, median to describe it. However, if you have categorical variables, you are going to use proportions or percentages to express the numerical value of your data. Now, the question is, why do we need to move on into significance testing, or why do we need to make inferences from the data concerned? Now, as we all know, we have seen earlier that when we want to study populations, due to time constraint or resources limitations, we do not study the entire population. What we do is, from the population, we draw a representative sample. The results of this sample can be used to draw conclusions about the population. So this is all the essence of understanding what is significance testing. So why do we need to test whether this sample results really match to the population results? Unless and until we do this, we do not know whether what we have done is right or wrong. Now, what is important is, if from the same population we draw two samples, or we have two different populations and we have one sample each from each population, the question which we are going to test is, if the two sample or the group means are different, can we be certain that the populations from which they are drawn are also different? So suppose we don't know whether the populations are different in characteristics, we can draw samples, we can compare the samples, and we can check whether the populations differ from each other. This is basically what we do when we test significance. Now the question next which comes in is, suppose we find a difference. For example, you have two values of sample means. For example, you draw samples from populations of men and women, and you try to look at the mean blood pressure of men and women. Now, you may find a difference. The values may be different. Now, the question here is whether this difference which you have obtained is true or it is spurious, or it's a false difference, or it is a difference merely by chance. So next question which also comes in, okay, this is one sample which we have drawn. How about drawing multiple samples or take another set of samples? Will this sample be different from the first or the second or the rest? Then if we find a difference in the repeatedly drawn samples, again, whether the difference is true or it is false. Now, so what we are doing at the end of all this is we are trying to find whether there is a difference between two group means or two means, and this answer is given by applying statistical tests. Now, when we talk of statistical tests, we are trying to look at whether the two groups which we have seen earlier are statistically different from each other. Now, it may not essentially be two groups, it may be more than two groups as well, but we are starting off with understanding differences between two groups. So, whether these two groups are statistically different from each other. So after application of the statistical test, as we have seen in the steps in hypothesis testing, we try to look at whether there is a difference which is statistically significant in the two groups. So now the question remains whether statistically different is equal to truly different and not just apparently different. So as we can see in the picture here, here is the picture of a tiger and another is a picture of a buffalo. So now, practically speaking, we do not need statistics to say that these two are truly different. These are definitely two different species. So a tiger is never going to match with a cow. So that's basically cow or a buffalo. So not for everything you need statistics to tell you the difference, but when you're dealing with numbers or when you're dealing with characteristics of variables, you are going to need statistical tests to tell you whether the difference which you can see maybe in terms of numbers is statistically significant or not, or it is just a difference by chance. Now, when we talk of statistical analysis, what is important is we need to look at the concept of mean. Now, just to have a quick recap of what we have seen earlier about types of variables or types of data is that when we talk of calculation of mean, we need a variable which is continuous in nature. So in other words, we need a quantitative variable. So referring back to the example of the blood pressure from two samples. Now, for example, if we do a study wherein we are trying to look at treatment given for control of blood pressure. So we have two groups whereby there is a group which receives a particular treatment and there is a group which does not receive treatment. So the group which receives treatment we consider as the treatment group, whereas the group which does not receive treatment considered as the control group. Now we measure the blood pressure values in both the groups of all the individuals, and then what we can calculate from this is a mean blood pressure value. So we will have a mean blood pressure value for the treatment group and we will have one mean blood pressure value for the control group. Now we need to compare these group means. Now as you can see in the figure shown here is the dotted lines are the lines representing the group means. So this dotted line to the left shows the mean blood pressure value of the people in the control group, whereas this dotted line represents the mean blood pressure of people in the treatment group. Now what you can see over here is there is a difference between the mean values in the control and treatment group. Now, whether this is a real difference or not, or it's a difference by chance, is what we are going to test by applying a statistical test. Now, this is about the mean, but what are these green and blue lines representing? These are nothing but the distribution of the blood pressure values around the mean. So, for example, if you have 100 people in the treatment group and 100 in the control group, this particular distribution is showing the values of all the 100 people, and the central value is nothing but our mean. So as we can see here, there is definitely a difference which is seen in the group mean values. But now the question which we are going to test is whether this difference which we see is a real difference. That means we are going to check whether the treatment has made the difference or whether it's a difference just by chance. Now when we are talking of this difference, what do we actually mean. So we come back to the same graph which we saw earlier. So I'm going to show you three different graphs wherein you can see the variability around the mean. So this particular graph which you can see is considered to have medium variability around the mean. That means the curve, as you can see, there is a peak. Okay, it's not a very steep or not a very sharp peak, and the variability around the mean is also considered to be medium. Let's look at the next one, then we understand better. Now if you look at this one, you understand that these are the means, whereas the variability around the mean is very high. So your data is widespread or dispersed more as compared to this particular spread of data. So this is known as high variability. We can have another variety wherein we can have the peaks going to be very narrowed or very sharp, and this is known as low variability. So what we are trying to look at over here is, these are your dotted lines are your mean values, and the green and the blue lines are going to represent the dispersion or variability around the mean. This represents low variability around the mean. All the values are very tightly packed next to the mean. This one has medium variability, wherein the values are a little bit dispersed from the mean. Whereas this one, the values are highly dispersed away from the mean. So it is called as high variability. Now, what we can observe here is very, very important, which we all need to understand is, if you look at both the dotted lines here, the mean difference is the same for all the cases. So if you take the difference from this value to the mean, it is going to be the same. Okay, whereas what's happening here is, we are going to test which one of these shows the greatest difference. So here the means are the mean differences remain the same, but the dispersion around the mean differs. So our question remains, which one is going to show the greatest difference? Now let's move on to understanding how does a statistical test work. Okay, now statistical test analyzes the data or the numbers submitted in your Excel sheet or in whatever type of data entry which you are using. And this helps us to calculate the chances of obtaining a difference when there is none. So sometimes we may see that there is a very small difference between the group means, but if you try to test it through statistical methods, it may come out to be statistically significant. So in other words, what we are testing is probability of obtaining a spurious or a false difference. Please understand that a statistical test does not indicate whether the study design which you have used is right or wrong. Secondly, it does not tell you whether the type of data which you have analyzed is right or wrong. Thirdly, it doesn't tell you the magnitude of difference in the two groups. That's not the purpose of a statistical test. And lastly, we can apply a statistical test, but whether clinically or practically this difference is useful or significant or not cannot be indicated by a statistical test. So what basically a statistical test can then prove or point out it is that whether the difference which you are observing between two groups or more than two groups, whether this difference is real difference or it is a difference by chance or a false difference. So that's what a statistical test is going to help you with. Now, what a statistical test will infer is, when you apply the statistical test to your data, you will test your statistical test results against what we call as a p-value, which we have seen earlier when we talked about hypothesis testing. Just to revise that, when your p-value is less than 0.05, in case you have set your alpha or critical value to 0.05, it shows that the chances of obtaining a false difference is very low, which is less than 5% or 1 in 20. Okay. So as your p-value, you go on reducing it, your chances, they become 1 in 100 or 1 in 1000 and so on. So that's about what is the inference which we draw from statistical tests. Okay. Now, because for all practical purposes, as I have already discussed, we consider our 5% probability, less than 5%, as comparatively small. So we can conclude that if we get any difference between two groups as less than 5%, we consider it as the difference between the groups as being true. Now, the most important aspect of this session is the choice of a statistical test. If we surf through the internet or if we use statistical packages, we come across names of different statistical tests. There are so many statistical tests which are available. But before we actually select a statistical test relevant to our data, we need to understand certain basics and certain basic concepts without which the application of the test is meaningless. So when we are talking about selection or choice of a statistical test, it will all depend on various factors. And the most important factors which I'm going to discuss today is, first is the type of your data, the type of analysis which you want to do, the study design, the distribution, whether it is a normal distribution, it is a probability distribution or a non-probability distribution, and last but very important, how many groups are there in your study, whether it is one group, two group, or more than two groups. So before moving on to understanding all this and the different permutations and combinations, we need to understand that there are two basic types of statistical tests. One are known as parametric tests and the others are known as non-parametric tests. Now the word parameter means that something which is related to the population when we have looked at hypothesis testing. So when we talk of parametric tests, we talk about tests which are applicable only to data which shows a normal distribution. For all other data which show a non-normal distribution, we will use non-parametric tests. Parametric tests will be used for data which are independent of one another. So when you use variables in a data set, they have to be independent of one another. Only then you can use parametric tests. And very important is, parametric tests can be used on data which are measured on continuous scale of measurement. In other words, you can apply parametric tests only to quantitative data. Please do remember this. Parametric tests are applicable only to quantitative data. So the quantitative data type includes continuous and discrete variables. So you can apply your parametric test only to these kind of variables, provided the data follows a normal distribution and the variables under study are independent of each other. If we look at non-parametric tests, as I said earlier, you can use it on data which shows a non-normal or distribution which is other than normal. Okay. Now for non-parametric tests, you can have variables which are dependent or conditional on one another. So which means that there can be one dependent and another independent variable, or there can be more than two dependent variables and so on. Okay. And in general, they do not have a continuous scale of measurement. So you can use non-parametric tests for categorical data. Okay, so this is the basic difference between parametric and non-parametric. Now the next slide which we are going to see shows you few names of parametric and non-parametric tests. Now there are, as I said earlier, there are several tests which are available, but which one to use all depends on certain factors which I have shown you earlier. Now before you go on to the looking at the examples of parametric and non-parametric tests, one practical example which we can have a look at is, if we look at parametric, the word parametric, if you have measured the length and weight of something which will have a unit, you can apply parametric tests. Whereas if you look at a condition wherein you are working in a lab and you are looking for growth of bacteria on a culture plate, you are looking basically for whether the bacteria has grown or not grown. So you just have this categorical data wherein you have two categories here, whether there is growth of bacteria or no growth of bacteria, right? And so we can apply non-parametric tests here. So choosing a statistical test, as I said, the examples here you can see the parametric test and the non-parametric tests. There are several tests, as I mentioned earlier, and not all have been covered in this list. This list can be expanded and there are various other examples. However, what I have done here is, what you can see, the parametric test for a normal distribution or for continuous data on this side, the relevant non-parametric test or the non-parametric test which can be used as a substitute if the data is non-normal is given on the other side. That's what I have tried to do. So the most common test which students generally are using are the student's t-test in the parametric variety and the chi-square test in the non-parametric variety. So in another session, we are going to look at details of the t-test and the chi-square test. Under t-test, we have paired t-test and unpaired t-test. Depending on the type of variables we are studying, we also have a concept of known as correlation, and we can have a Pearson's correlation test for parametric and a Spearman's rank correlation for non-parametric. As I said earlier, choice of the statistical test also depends on the number of groups. T-test is applied when we have two groups to be compared, whereas ANOVA is nothing but a variant of t-test which we apply when we have more than two groups, and there are various types of ANOVA, one way and two way and so on. So these are the different types of test names or statistical test names which you can come across when you are using statistical packages. Now the question remains how to select appropriate statistical test. Now for convenience, I have divided this selection of appropriate tests into three things. So first and most important is you have to look at what are the type of variables in your study, whether you have quantitative or categorical or qualitative. So for example, quantitative type of examples are blood pressure, pulse rate, height, weight. Categorical is gender or maybe level of education or grade of a disease or staging of cancer. All this will come under qualitative or categorical. Next thing which is important is what is the type of research question, whether you are trying to study association between a risk factor and a disease, in which case you can understand that the type of variables you have dependent as well as independent, or you are trying to compare two groups. For example, we saw earlier whether you have a treatment group and a control group, or you are trying to study whether a factor associated with a disease is a risk factor. So depending on what you are trying to study, what is the objective of your study, you can decide on the statistical test. And as I said earlier, you have to look at the type of variables, whether you have independent, dependent, you have paired variables or matched variables or so on. So quickly let's look at when you're talking of association of two variables, what are we looking at? If your variables are dependent and independent, and what is the type under that will decide what test you can use. For example, if you have two variables which you are trying to compare, which we call as bivariate analysis, you have one dependent variable which is categorical in nature and the other one is independent, which is again categorical in nature. You are going to apply a chi-square test. So for example, if you are trying to look at a study of association between gender and level of education, for example, what you have here is you have a categorical variable, gender and education, and of which either one can be dependent or independent. And both are categorical because gender we are going to put them under male, female, and education can be any type, maybe primary, secondary, tertiary, and so on. So for this kind of data, you're going to apply the chi-square test. Now the same thing with a little bit of variation wherein your independent variable, if it is quantitative in nature, for example, you are considering gender and you are considering blood pressure, for example, you can apply what we call as logistic regression because you're trying to study the association between gender and blood pressure. Now, if you have the dependent variable as quantitative and the independent variable as categorical, if you have two groups, you will use t-test. If you have two groups means two outcomes, you will use t-test. But if you have more than two groups, you will use ANOVA. And if you have two variables which are quantitative in nature, you will use Spearman correlation or linear regression. So these are various types of tests which you can use in practice if you are trying to study association of two variables. Now if you are trying to compare the difference between the variables, so for example we looked at difference between the group means and so on. If you look at your variable here, if you have quantitative variables, you are going to use your parametric test, that is t-test for two groups, ANOVA for more than two groups, and there is a paired t-test if you have a paired data. As I have discussed earlier that in students t-test we have paired and unpaired t-test. If you have your data as ordinal, which is again qualitative type of data, you are going to use the non-parametric test. If it is two groups, you will use Mann-Whitney. If it is paired data, you will use Wilcoxon. And if it is more than two groups, you will use Kruskal-Wallis test. So you don't have to remember the names of the tests as such. You have to remember for what kind of data, what kind of test can be used. Because use of statistical packages will help you get to know what these tests all mean. Whereas if you have a categorical variable and you have two groups to be studied in the independent variable, you can use chi-square test. If it is paired data, you will use McNemar's test, and if it is more than two groups, you can still use chi-square. So chi-square test in non-parametric variety you can use for two groups or more than two groups. Whereas in a parametric test, t-test can be used only for two groups, but for more than two groups, we go for ANOVA test. Lastly, if we are studying the risk factor, for example, if you are talking of doing a study between smoking and lung cancer, for example, and you also want to check whether there is smoking is associated with pancreatic cancer. So in that case, you have one risk factor, that is smoking, and you have several independent factors, that is lung cancer and pancreatic cancer. So if you have categorical dependent and categorical independent, you can use multiple logistic regression. Now this is the higher level of statistics, wherein what we call as predictor analysis. As I said earlier, inferential statistics can also be made to predict whether a particular factor associated can be a risk factor of the disease or not. Then if you have quantitative dependent variable compared with categorical independent, you can use the ANOVA test. And lastly, if you have quantitative dependent and quantitative independent as well, you can use logistic regression or linear logistic regression. So this is about understanding what kind of study design you are adopting or what is the objective of your study. Now there is another table which you can check for choosing statistical tests, and this table has been taken from graphpad.com. It is easily available, and if you look at this table, looks like quite complex. However, if you look at what is your objective, you can easily understand what is the test you can select. So the same test which I have shown in my earlier slides can be seen here with few tests being added, and there can be several others also which may not be included here. But what is important is for basic analysis we need to understand this much. So as I said earlier, when you're choosing a statistical test, you please look at what is the type of your data. When I mean type of data is basically nothing but whether it is quantitative, whether it is categorical, whether it is continuous or discrete and all that. Second important thing is you look at the distribution of your data. So if it is normal distribution and it is a continuous data, you can use parametric tests. Next, as we have seen earlier, what is the analysis type which you want to do, whether you want to study association, whether you want to study the risk factor, or you want to study difference between two groups, you have to select the test accordingly. Next is the number of groups, whether it is one group, two group, or more than two groups. And last but very important is what is your study design. So whether yours is a analytical study or an experimental study, all will determine what type of test you will use. Now if you look at this table, what is given in blue is what is your goal or your objective of analysis. That's one. And second, what is the type of data which is being used. Okay, so for example, let's look at this one. If you are comparing two unpaired groups, okay, now your goal is basically to compare two groups, right? Now our example of treatment and control group means, okay, in this case your groups are having mean blood pressure value, so it is a continuous type of data. And if you have this measurement from Gaussian population, Gaussian is nothing but your normal distribution, in this case you can use unpaired t-test, okay, because you have two groups which are not paired, they are two different groups. However, if you have two paired groups, you can use paired t-test. Now what do I mean by two paired groups? Look at a group whose blood pressure you monitor, okay, then you administer a drug to all the people in the group, and for every member of the group you will measure the blood pressure post administration of the drug. So what we have here is one person in the whole group will serve as pair for himself or herself when we do a pre and a post examination of blood pressure. This becomes what we call as a pair. So it is essentially the same person, but it is measured on two occasions. So in this case, it was like before administration of the drug, the BP was measured. So that becomes the pre-group. And after administration of the drug, the BP was measured again, which becomes the post-group. So this is nothing but comparison of two paired groups wherein we will apply the paired t-test. Now, as I said earlier, if you have same situation but you have three or more unmatched groups, that means you have three groups or more than three groups which are unrelated to each other, you are going to apply the one-way ANOVA. And before that, if you have only one group and you want to test whether this group is significantly different from a hypothetical value. Now, what is this hypothetical value? Is nothing but if you want to check that a sample drawn from the population, whether it represents the population or not, you will have only one group, in which case you are going to use one sample t-test. So t-test has got various variants, and if you have more than two groups in parametric data, you will use nothing but one-way ANOVA. Now, when you see this particular column, what you can see here is if you have a non-Gaussian population or a variable which doesn't have a normal distribution, then what you do is you will apply the non-parametric test. So what this table shows is the counterpart of one sample t-test in a non-parametric test is Wilcoxon test. Okay. For unpaired t-test, it is Mann-Whitney test. For paired t-test, it is Wilcoxon test. So for t-tests, you have different variances here. And for one-way ANOVA, you have Kruskal-Wallis test, and so on. If you have two possible outcomes, okay, then which we call as binomial type of data, we will use these kind of tests. So this is all about understanding what is the different type of data and the distribution of data. So that's all from me today. Please keep watching and do subscribe, and we'll come with the next session on the t-test. Keep watching. Take care. Bye.